Continuing to Newton's laws of motion, illustration problem 3.3. The 50 kilogram crate shown in figure 3.10 rests on a horizontal surface for which the coefficient of kinetic friction is 0.3. Okay, if the crate is subjected to a 400 Newton towing force as shown, okay, determine the velocity of the crate in 3 seconds starting from rest. Okay, so we need to determine the velocity of the crate in 3 seconds from rest or starting point. So a towing force is applied as shown, that is 400 newtons at an angle of 30 degrees. So as you can see, there's a kinetic friction, or something is mu k, that is simply the symbol for kinetic friction, which is equivalent to 0.3. Now every time we encounter some of these problems, we need to draw an FBD. FBD is simply the free body diagram. Okay, so that is the horizontal plane where the crate will slide. Okay, and this serves as the crate. Okay, now there's a towing force, 400 newtons. Okay, 30 degrees, similar to this one. Okay, just like drawing it on a front view. Okay, now let's say there's a person here that is pulling this crate at an angle of 30 degrees with a force of 400 newtons. Okay, now the component of this is that the crate has its weight. When we say weight, that is directed downward. Okay, and there should be a normal force acting on this crate and that surface, and normal force is always perpendicular to the surface. Okay, so that is acting upward. Weight is downward. Okay, always downward, and then the normal force acts perpendicular to the plane. That is the normal force. So that is, but first we need to determine the x and y component of the applied force, which is 400 newtons. So x component, okay, 400 cosine 30 degrees, and the y component of this force is 400 sine 30 degrees. Now a frictional force will be available. So without frictional force, if that is applied, then if the force has stopped, then this will continue to move or slide and will never stop without friction. Okay, so frictional force is always opposite the direction of the movement or motion of the crate or object. So if you pull this 400 newtons, the direction probably is going to the right, and the frictional force is opposite that direction. Okay, and the weight is simply downward direction, and the normal force on the crate is always perpendicular to the surface. Okay, so if this is your surface, okay, this is your surface, okay, normal force always acts normal to that surface, and that has an angle of 90 degrees. Okay, this is the normal force. Okay, now solving for the weight of the crate. Formula for weight is mass multiplied by acceleration due to gravity. Okay, so weight is equivalent to mg. So mass of the crate is given 50 kilogram. Okay, and acceleration due to gravity is constant 9.81 meter per second squared. So you'll have the weight of the crate as 490.5 newtons. So you can always solve for weight using formula provided the mass is given and acceleration due to gravity is constant. Okay, now the frictional force is, or has a formula of Okay, frictional force will be equal to the coefficient of kinetic friction multiplied by the normal force. So kinetic friction is 0.3 and the normal force of the grate is unknown. So this is unknown yet. Okay, so let's just say that this is an equation from the FBD. Okay, so considering that applied force 400 Newton and there's movement or motion along this direction. Okay, that is the movement or the motion of acceleration. So this is moving. Okay, so summation of forces along x will be equal to ma, mass multiplied by acceleration. Okay, mass of the body. Okay, so summation of forces along x, so all the x components, okay, you need to add them. So positive direction is to the right and negative direction serves as negative. So let's say horizontal along x. Okay, so this is horizontally going to the positive x direction, and another one is the frictional force that is opposite the motion of the grate. Okay, so this serves as negative, so therefore that is 400 cosine 30 then minus frictional force of 0.3 normal force will be equal to ma, mass of the grate is 50 and its acceleration is unknown. So this serves as equation 1. Now, summation of forces along y. So summation of forces along y will be equal to ma, okay, mass acceleration along y. So is there any movement of up or down based on the crate? If you pull the crate, so tendency, the motion is simply horizontally. There's no ups or down movement of the crate. So therefore, acceleration along y will be 0. So 0 multiplied by 50 is 0. Now, summation of forces along y, so there are y components, those are vertical components. So going up is positive, going down negative. So as you can see, vertical component is going up 400 sine, okay, and another going up normal force, and going down is the weight. So 400 sine 30 plus the normal force, okay, minus the weight, which is equivalent to 490.5. Okay, so you can solve for normal force. Okay, so normal force is 290.5 newtons. Then substituting the value of the normal force to equation 1, you'll get 400 cosine 30 degrees minus 0.3 normal force of 290.5 will be equal to 50 multiplied by acceleration. Then you can solve for the acceleration, that is 5.19 meter per second squared. So this is the magnitude. Okay, so the magnitude of the acceleration. So summarizing, okay, so that is the FBD. These are solved earlier. Okay, now since the applied force P is constant, acceleration is constant. Okay, so applied force is constant of 400, so the acceleration is constant all throughout the motion. So therefore the initial velocity is 0 starting from rest, and the velocity at the crate in 3 seconds will be, using the formula straight line motion, that is final velocity equivalent to initial velocity plus acceleration multiplied by time. Since crate is at initial, it is at rest, so initial velocity is 0 and acceleration is constant, so that's 5.19, and the time given is 3. Simplifying, you'll get a final velocity of 15.15 57 meter per second.